In this short video we're going to look at ANOVA tests. Now ANOVA tests are ways of telling whether a population of samples are different from another population of samples. For example, are shells on one side of the beach larger than on the other side of the beach? Or are craters on the moon larger in the lunar lowlands than the lunar highlands? These are the sort of questions we could answer with an ANOVA test. Analysis of variance. So here we are at the home page of the Image Analysis and Spatial Statistics website, and we're going to go to the More column, which has a Resources drop down. So we go to Resources, takes us to the Resources page, and here we have the various pieces of software that we're using on the course, and also links to online tools, for example the ANOVA test. So we click on that here. And this page has got a little bump about how the ANOVA works, but the bit we're interested in is here at the bottom. The numbers of types of sample you have. For example, if you're looking at the shells, you'd have the beach by the sea and maybe the beach far from the sea. Or if the moon, you'd be looking at the lunar lowlands and the lunar highlands. And then you have the number of samples. Now, is this 20 shells from each location, or 200 shells from each location, or 20 craters or 200 craters? Now, because our community is so mixed, we thought we would analyse something that we all know. So what we're going to do is compare the reviewer scores for two movies. This movie, Star Wars The Phantom Menace, and this movie, Star Wars A New Hope. I think it's pretty clear to all of us which one of these movies should have the higher review scores. So let's try it out online. So we have two types of review scores for each of the Star Wars movies, and let's say we have 10 reviewer scores. Okay, so underneath that we have here on the left hand side some data entry boxes where we put in the scores. So let's call sample 1 Star Wars A New Hope, or the other one. No, the first one, The Phantom Menace. So these are the Phantom Menace scores: 25, 35, 30, 25, 34, 40, 42, 28, 27, 26. Not very good review scores. And here we have the review scores for Star Wars A New Hope: 78, 80, 78, 75, 67, 80, 77, 78, 67, 80, 70. Okay, so we've entered those, and then we can put calculate. Okay, so there's a big table here with various sorts of outputs, but what we're most interested in is this section here towards the bottom, the ANOVA summary. So what we have here on the far right of this is the P number. Now this is the number that we're really most interested in ANOVA tests. It tells us whether there's a significant difference or not between the two populations. If the number is P is less than 0.05, for example, it means there's a 5% chance at least that the samples are significantly different from each other. And here we can see it is less than 0.0001, so it's very much statistically likely that these two populations of scores are different. So we know that. Good. So we know that statistically the reviewer scores for A New Hope are higher by far than the reviewer scores for The Phantom Menace. Now, we can make things more complicated. We don't have to just do two samples in our analysis. We could also add these films: Star Wars Attack of the Clones and Star Wars Empire Strikes Back. So now we have 4 films to compare. Sample number 3. This one is Attack of the Clones, which was slightly better received than The Phantom Menace, but not much. So there's 40%, 37, 41, 37, 38, 42, 35, 30. So I've put in scores that are just a bit above those for the first movie. And Star Wars Empire Strikes Back was very well received, about the same as Star Wars A New Hope, so we'll put some scores in that are similar. $75, $67, $80, $67, $90, $83, $80, $72. Right, now we hit calculate. Now the table is getting a bit more complicated. So we still have the same p-value, still very significantly different. But now, because we've got 4 different films, we're quite interested to know between which films are these differences significant. So that's where we look here, this Tukey HSD test. Now this will tell us between what levels the things are significant. So movie 1 versus movie 2 is significant at least, so 99%, it says P is less than 0.01. That means that there's a 99% chance that movie 1 reviews are different to movie 2 reviews. That's what we did in the initial test, so it's 99%. It says that there's no difference in the reviewer scores between movie 1 and movie 3. So that's the 2 new Star Wars movies, Phantom Menace and Attack of the Clones. No significant difference. Between movies 1 and 4, between Phantom Menace and Empire Strikes Back, again it's 99% chance there's a difference. Between 2 and 3, there's a 99% chance there's a difference. So that's between Star Wars A New Hope and Phantom Menace. But between movies 2 and 4, so that's between Star Wars A New Hope and Star Wars Empire Strikes Back, it's a non-significant difference. So even though the scores were slightly higher, the spread of the numbers means that difference is non-significant. And between movies 3 and 4, so that's between Attack of the Clones and Empire Strikes Back, again a 99% chance of significant difference. Now what would happen if we had an outlier in these numbers? So what we're going to do now is going to go back and we're going to change someone's score from Phantom Menace to 95. Maybe someone really loved that movie somewhere in the world, so we'll give that 95. And we see what that does now. So we calculate again. You saw that these numbers changed a little bit. There's still a significant difference. It's made no real effect here. All of the things we talked about, all the p-values are still the same. So if you have just a 1 or so outlier in your data, for example, maybe when you're on the beach and you measure a shell incorrectly, maybe you even get an order of magnitude wrong, providing you've got quite a few samples, the ANOVA will not be distracted by that, and you will still get a reasonable outcome from your data. The averages are very different, even though there is the occasional outlier in the data. That's the end of this. Thank you for listening.